this is the set of notes that we started on on Monday, and then we continued on Wednesday. And there's a lot of stuff in here, and I feel like even though this isn't on the syllabus for our class, like I feel like a lot of people kind of forget this from like either high school or like your last math class. And it's really important to kind of understand like these exponent laws because you're going to see them a lot throughout the rest of the semester. And I am going to continue my sitting journey here because last time I stood during this class and my back hurt really bad when I got home. So I'm gonna try sitting down, right? Okay, so we talked about algebra and we talked about these things called exponents, right? What does an exponent mean? Like, what does an exponent tell us to do? Does anyone remember?
Multiply itself by the base.
Yeah, multiply the base by itself, the exponent amount of times, right? So like b to the 10th means b times b times b times b times b 10 times, right? Now, I told you that in your previous math classes, you might have been given a bunch of laws, like I gave you 7 here. And usually what teachers do is they'll give you a law and they'll be like, oh, memorize the laws, know where to apply them, and then you'll be good for the rest of the semester. That is totally an option for you. If you would like to memorize them and just use them from memory, that's totally fine. But I told you, instead of memorizing them, sometimes I like to think about why they work. So you're not just like memorizing these laws just to forget them like in a couple months from now. So we went through 7 of these laws. We talked about why they worked. I'm going to just kind of refer to the laws as we go through, but if you ever get confused by a law, you can always like go back to the definition of exponents and try to figure out, okay, like what's actually going on here and so forth. By the way, if you are new, don't like frantically write down stuff right now. You can take a picture of my notes after class. Okay. So last class we started a few examples. So we talked about simplifying stuff, which just meant, okay, I don't want any negative exponents. Generally you want one of each letter. Normally, sometimes that doesn't really always work, but normally like, okay, we want like 1A, 1B, 1C. And try not to have as many parentheses when we're simplifying stuff, especially if we're expanding something, because, well, they don't really look that nice and you can always use a law to simplify it further down. So we started with an example, example 1, which is a little bit easier. And oh, we finished example 2. All right. So we use the laws in example 2 to simplify this one down as well. If you flip to the next page, we have 2 more examples. How do you guys feel about trying these on your own? How about this? I'm gonna give you like 6-ish minutes. Why don't you get with the person sitting next to you, or if you're not sitting next to someone, turn around and work with the person behind you. I would like you to work on example 3 and 4. Try to get their name and maybe phone numbers. All right, let's come back up to the front here. Let me get names down. Emily, right? Okay, Emily, I promise I'm not just picking on you. I'll pick on everyone in this class. You just happen to be the first one. Do you kind of want to explain what you did for example 3? Mm-hmm. Oh, okay. Now I see what the question was here. I think you just wrote a -6 here when it should be +6, right? Yeah, so you did the right work. I think you just wrote a negative sign when you didn't mean to. Yeah, that looks really good. I hate to make Emily go first because she literally just came in this class, but I guess it's a good introduction to the class. All right. Any questions on example 3? All right, I think example 4 was a little bit more like complicated, I think. So why don't we just go through this one together? I did see a lot of good work walking around. The more complicated these become, like I feel like the more steps there are and the more different ways you can go about doing this. So if this isn't exactly what you do, don't freak out, but we should all agree on the final answer. Okay. Now taking a look at this example, I see something to the 0 power. What's anything to the 0 power? 1, right? So, I mean, I can write the 1 there, but honestly, like when you're multiplying something by 1, it doesn't really matter. So I'm just gonna kind of ignore that and like just not write it, okay? Now, taking a look at this thing here, right? I mean, there's a lot of stuff going on here. What did you guys do first? Um, uh, mm, I'm getting names. I'm getting them. I promise. Amir.
I'm multiplied everything by the -3.
Multiplied everything by the -3, or take everything to the exponent, right? So you took that -3, you brought it to the top. You also brought it to the bottom. I think you probably did them to the individual terms, right? I'm gonna like not skip that step. It's totally fine if you do skip that step, but I'm gonna just keep this as u to the 2 to the -3 and 2v to the -3. Okay. Now, I know a lot of you kind of skipped over that, and that's totally fine. I just want to show this just in case you don't see the way that we got there. Okay. All right, next. I don't know. We have a bunch of stuff going on. What can we do up top? I think, wait, oh, what did, I think I heard something.
Yeah, distribute -3.
Distribute, but like, do you add, multiply? Multiply, right? So this becomes u to the -6, right? On the bottom, we have to do something a little bit different. We don't multiply. What do? We don't add either. Yeah, like we distribute, we give it to each of the terms, right? So the 2 gets the -3 and the v gets the -3 as well. Walking around, I did see some people forget to put the -3 on the 2. The -3 goes on everything, including the numbers as well. Okay. Continuing on, I know a lot of you, okay, we're like, okay, we got negative exponents. I don't like negative exponents, but I also don't like the 2 raised to the -3rd power. So I saw a lot of you like type this into your calculator and like rewrite this as 1/8. You can do that, but honestly, I like typing stuff in my calculator when I have positive exponents. So because the 2 is to the -3, I kind of want to bring it up top before I type it into my calculator and figure out what it is. I think it makes it a little bit easier. So let's keep going. How do I make the negatives turn into positives? Flip them, right? So like the 2 to the -3 goes on top and it'd be 2 to the +3. The v to the -3 will go on top and be v to the +3. And then the u does the same thing, but it goes to the bottom and it turns positive. Okay. Does everyone kind of see how I did that? Okay. Once you're here, it becomes really easy to find what 2 to the cubed is because a lot of us know what it is. Sometimes you might need your calculator. What is 2 cubed? 8, right? So 8b cubed over u to the 6. And well, we have one of each variable. We don't have any numbers being squared or cubed or anything. This is a pretty simplified version of what I have. Okay. Any questions on what I've done for example 4? Cool. All right, I know that there's a lot of steps. Now, if you feel a little like iffy about doing these, if this was a little struggle to like get through these questions, I don't put that much on the homework. I would recommend going through those extra credit worksheets. I did put one up for just regular like simplifying expressions. There's a bunch of questions on there with the answers. So I would recommend just starting that worksheet, going through that, and then you get some extra credit for it, which is nice. We don't have that much time in this class to go through like a bunch of examples. I try to do hands-on stuff as much as possible, but if you feel like you need more practice, I definitely recommend doing those extra credit worksheets. Okay, we're gonna make it a little bit harder, okay? Because we're gonna throw not just whole numbers, but fractions into the mix, okay? Now, we've seen exponents with negatives, we've seen regular exponents. What happens when our exponent's a fraction? Gets a little bit more complicated, right? Has anyone seen an exponent that looks like this? 3 to the 1/2 power? Yeah, exactly. If you see something to the 1/2 power, it's the same as this thing that we call the square root. If you've ever heard of that one, this symbol. Yeah, I know a lot of you have seen that symbol before, but what a lot of people don't know is that symbol literally means something taken to the 1/2 power. Okay. Another way to write the symbol that a lot of people don't know is you can actually write it like this. It's basically the same symbol, but with a 2 in that little like cranny, that little nook like in the square root symbol. And that's what it also means. Okay. Now you're probably wondering, like, okay, how do I raise something to the 1/2 power? Like, I can't multiply something by itself a half times, right? That doesn't make any sense. This is what this means, okay? 3 to the 1/2 power. I'm going to write this down here, okay? And I'm actually going to multiply it by itself, okay? So I'm going to take 3 to the 1/2 times 3 to the 1/2, okay? Now, if I have the same base and I'm multiplying it with like exponents involved, do I add the exponents or do I multiply? You add the exponents, right? So if I were to go ahead and do this, it would be 1/2 plus 1/2. What is 1/2 plus 1/2? 1, okay? So basically what a square root is it saying the square root of a number 3, for example, is the number that you multiply by itself twice to get the inside of the square root, or 3, okay? That's what a square root is. So it's basically like doing an exponent, but going backwards to figure out like what is actually being raised to the power, okay? So, well, we know what a square root is. You might not have seen this before, but we actually have other roots, okay? So for example, 3 to the 1/6 power is also an example of a root. It's called a 6th root. Not a very good name for it. It's very obvious. But 3 to the 1/6 power is the number that you multiply by itself 6 times to get 3, okay? And this is how you'd write it, okay? You'd write the square root symbol, you put 3 on the inside, but in that cranny, we now have a 6, okay? So it's kind of just a different notation to write like a power. It looks a little bit more slick. I don't know. Yeah, Zach.
I wonder if there are any other just a square root with 6 root. How would you figure that out?
Oh, like how would I find that on the calculator? Yeah. So let's just say you were on your calculator. You want to figure out what the 6th root of 3 is. Your calculator doesn't like do it using this notation, but what I would do is convert it back to this fractional notation. Okay. On your calculator, do 3 caret, right? Now, when you have fractional exponents, your calculator is going to need to know like where the exponent starts or stops. So you're going to need to write a parentheses, right? 1/6 to show the fraction, and then close the parentheses. So now your calculator knows like, oh, there's a fraction in my exponent. I'm not just raising 3 to the power of 1 and then dividing by 6. You're like grouping it together so your calculator knows. Yeah, but that's how you would go ahead and your calculator do it.
Isn't witness when you use different dimensions and stuff like square footage? Isn't this?
Yeah. If you go to different dimensions, we'll definitely see like different roots as well.
Yeah,
I would say,
because I was looking at this problem the other day. There was like I was trying to find the square footage or something, but to reverse that, I had to.
yeah, you had to take square
Find the
root.
square root. So I started thinking like if I'm finding the square footage, then I can find cube. And then I can find
Volume.
yeah.
Going even further, there's even more dimensions than 3
I know,
dimensions.
and then that's
Yep.
that's funny.
Yep. That's where it comes about.
The fourth dimension is mine.
Yeah. It's honestly kind of hard to see the 4th dimension. There's a thing called a hypercube. If you ever want to Google that, there's like a video that shows what a hypercube looks like, and it's very interesting.
Like the tesseract of fourth dimension?
Yes, it is. It's
I don't even know what a tesseract
Is
is.
No,
it
it's
a cube
a
or like
tesseract is a
suspended
fourth
in a
dimensional
cube?
geometry.
Yeah, that's a hypercube. Yeah.
Oh,
Yeah. Yeah. It's very interesting. I try to wrap my mind around it. It's not my specialty. My my specialty in grad school was it was a little bit different than that stuff. I don't know how people wrap their minds around that stuff. It blows my mind. Yeah, it's
very long and extensive pattern.
yeah.
And it's just hard to
Now I did a lot of algebra for grad school. My specialty was cryptography, so like any crypto stuff was what I dealt with. I didn't deal with any shapes or anything like that. I stuck with just formulas and equations. It made me feel good. I don't know how other people deal with the bendy shapes or whatever. All right. But in general, if you ever see like a number raised to a fraction, you can always rewrite it in like this other form, like a root form. Just sticking the exponent like bottom number in like the little nook, and then putting the base like inside the square root. Okay. So I just want to do some practice like using this notation. how would I write 7 to the 1/10 power? What would go inside the square root symbol? 7, good. And what would be in like the little nook?
That's it.
10, perfect. Okay, now I'm like not precise enough to write the 10 like in that little crack, but I try my best. Okay, what about 4 to the 7/6? That one's a little bit more tough. Like when this one, it was easy because it was like 1 over something. Now we have 7 over something. Okay, here's where it gets a little tricky because you don't know. Like, I mean, I guess 6 might go in the cranny, but like what goes what goes inside the square root, right? Let me show you how I would go about thinking about it. You don't have to do this every time, but I just want to show you what happens and why it happens. Okay. I'm actually going to rewrite this in a different way. Okay. Instead of writing 4 to the 7/6, I'm going to rewrite it like this: 4 to the 7th power, all raised to the 1/6 power. Can someone tell me why the left hand and the right hand sides are equal? Yeah.
So since it's, well, I thought about it as it's an improper fraction. So you can take the numerator and multiply it, or put that
Yeah.
exponent on the floor and then take the 6 and make that 1/6.
Yeah, it's an improper fraction, right? I don't know if it's I don't know if improper fraction is the right term, but I think I know what you mean.
Yeah.
What were you gonna say?
Well, when you multiply like whole numbers with fractions, you never really multiply. When you multiply the denominator, but the whole number would have a denominator of 1. When you're multiplying both, 7 would go with 2. 6 would stay the same.
Perfect, right? And I think that's what you meant to say, right? Like whenever you have an exponent to an exponent, you multiply the exponents together. So 7 times 1/6. I mean, I think you called it improper fraction, but it's just like multiplying together. This would become 7/6, right? So basically, I just rewrote this in a way where it looks different, but it's the same number. Okay. So, any idea on how I would write this as a principal root now? What would go inside the square root? 4 to the 7th power, and the inside or the little nook would say 6, right? Now, in general, you don't have to do this step like before you write it. Basically, if you have a number up top in your exponent, it kind of goes with the base and it goes inside the square root, and then the denominator gets put in like the little nook. Okay. All right, knowing that, how would I write the 6th root of 2 to the 5th as a exponent? Um, yeah, 2 to the 5/6, right? So you can go backwards as well. What about, well, this one is the square root of b to the 5th power. Anyone want to guess what the exponent is now? Zach?
Correct. B to the 5/2.
And why is it 2?
Because square root, like without any of those, it's a square.
Perfect. Yep. So whenever you have something without anything in the nook, it's basically just like pretending that you have a 2 there, but square roots are so widely used that we usually don't write it. No. Because just think about it, it'd be like 1/1. And then that would just be itself, right? Yeah. That was a good question though. Don't think there's a 0 root either. That would make sense. Yeah. Yeah, that would be weird. All right. Now you're probably wondering, okay, well, are there any rules for fractional exponents? No, they work exactly the same as the rules that we learned before in the beginning. Those 7 rules that we learned on the first page of these notes, they work for fractional exponents. Now you're just dealing with fractions. I know it's scary because, well, fractions themselves are kind of scary to deal with. But I promise you, like working with these is basically the same as just working with regular exponents. So what I want to do is kind of go through some examples, just so we kind of get used to working with these exponents, even if we have fractions. And I know it's scary. I promise it won't be that bad. But let's just take it a simple one. 3 to the 5/4 to the 6th power. Okay. Now, remember, these exponents are literally the same. Like, it doesn't matter if there's a fraction. Just pretend it doesn't have a fraction and try to figure out what rule to use. We have an exponent raised to another exponent. Do we add or multiply the exponents? Multiply, right? So the answer to this would be 3 to the 5/4 power times 6. Okay. Now you can do this. You can do this in your head. Let me just show you what you would type into your calculator to deal with fractions, and then we can deal with doing this in our head. Um, personally, personally, I hate fractions. Like I don't like working with them. I don't know, it kind of scares me. So whenever I deal with like fraction multiplication or addition, I usually like we are allowed to use our calculator for this class. So I just think it's easier to type this in your calculator first and then figure out what the fraction is. If you want, we can do it together in our heads as well. So if you were to try to figure out what this is, like 5/4 times 6, what you would do is if you have your graphing calculator, I would write in parentheses 5/4, right, to represent the fraction. I would multiply it by 6 and can someone, oh, what is it? 7.1. Okay. Now, 7.5. Perfect. Okay. Now, in this class, we are discouraged from telling you to use decimals.
Okay.
So, no, that's good. I wanted you to say 7.5. Yeah, so like using your calculator, it's like, oh, well, that's not very helpful because I don't want to put 7.5 in the exponent, right? Here's a little trick you can use on your graphing calculator, okay? On your graphing calculator, do you see a button that says math in all caps? Okay, press that, okay? Once you press it, you're gonna see a little button that says arrow frac, I think. Do you see that? Frac. Click that one, okay? Just press enter and then enter again. And it should take whatever you have that that came out last, like 7.5. It's going to take that and turn it into a fraction. And what do you get? 15/2. Okay. So if you feel uncomfortable with fractions, I don't really care if you use your calculator to just do this and get that fraction if you'd like. But let's just do it in our heads. So just in case you forget your calculator on the test, you can also do it. Okay. We have 5/4 times 6. Does the 6 get multiplied to both the top and bottom? No, it just gets multiplied to the top. So this becomes 30/4. Okay. Is that a simplified fraction? No, they're both divisible by 2, right? So this becomes 15/2, which would work. Okay. Now you're probably wondering, what's more simplified, like a fractional exponent or the root form? To me, I don't care. On a test or quiz, you can leave it like this. You can also rewrite this as the square root of 3 to the 15th, right? That's another way to write this. Either one works for me. I will say on Alex, you might have to read the directions to figure out if it wants the fraction form or if it wants the square root form. But either one will work for me. Yeah.
I know obviously the TI-84 plus, there is just an option to make it always go fraction.
Oh, I had no idea.
Load and scroll down to see answers colon and then click frac and it said text.
Okay, so answer colon frac.
Yeah,
Okay.
you use the D-pad to highlight the fraction, click enter, and it will make it looks like the answer.
Oh, I had no idea about
That's
that.
on T80. I don't know about the 83 plus. But
Okay.
That's how it was paid.
It should work with the 83 plus then. Yeah, so if you want to just have your answers default to a fraction, then go ahead and do that. I had no idea about that. Thanks.
Yeah, I can't remember how, I don't even know how I remember how to do that because it's so long.
Hey, that's great. All right, why don't we do one more example? Here we have example number 7, okay? And now we have a bunch of stuff going on with fractional exponents and a bunch of different steps to do. But I promise you they work the same as you normally would use them, okay? So taking a look at this example, I don't know, any ideas on what we can do to simplify this a little bit better? Yeah, that there's a bunch of stuff being raised to its power, right? So maybe I can distribute that 1/3 to both the 8 and the x, and then it will take away like the need for those parentheses and all of that stuff. So why don't we go ahead and do that? We have 8 to the 1/3 power, okay? We have x to the 1/3 power. And I can even get rid of the parentheses now because like we don't really need them anymore. All right.
You got to do 163.
Do I need to do that?
No, they're on the inside, I'm sorry.
Yeah, I don't need to move that 1/6 to the 3 because that's inside the parentheses. No, that's a good observation there. Yeah, if the exponent is on the inside the parentheses, you don't need to distribute it to everything inside. Okay, so we're getting there. What is 8 to the 1/3 power? 2, right? It's what needs to be multiplied 3 times to get 8. If you don't know that, you can always just go in your calculator and do 8 caret 1/3, and it should give you 2. Okay, so, okay, 8 to the 1/3 power, that's 2. Okay, now we have x to the 1/3 power and x to the 1/6 power. What do we do with the fractions? Do we add them, multiply them? Add them, right? If they have the same base, different exponents, and they're being multiplied together, we're actually going to take those and add them together. So this becomes 1/3 plus 1/6. Okay, we'll figure that out. And then I can't forget about the 3, right? I also have to remember the 3. Okay. Everyone see what I did so far? Cool. Okay. Now my next step, well, I can do 2 times 3. That's easy. So I'm going to do that first. This becomes 6x to the 1/3 plus 1/6 power. Okay. Now, of course, you can use your calculator and figure out what 1/3 plus 1/6 is. You can transfer it into a fraction. Let's just go over how we would do this without the calculator because I feel like we haven't seen fractions in a long time. So let's just do on the side. Let's do 1/3 plus 1/6. Okay. Does anyone remember the thing that you have to find first when you're adding 2 fractions? Common denominator. What is the common denominator here? 6. Good. So both of these should be over 6. Okay. 1/6 is already over 6. How do we get to the 3 to a 6? What needs to be on the numerator? 2, right? And if you kind of forgot how to do that, you basically figure out what you need to multiply 3 by to get 6, and then you multiply that by the top as well. So this becomes 2/6 plus 1/6. This becomes 3/6. Okay. What is another way to say 3/6? 1/2. Perfect. Okay. So instead of saying 6x to the 1/3 plus 1/6, we can say 6x to the half power. All right. So this is a totally fine way of writing your answer. I would mark this right on a test or quiz. If Alex asked you to write this as a root, then it's the square root of x, right? So you can also do that as well. All right. Any questions on example 7? All right. Well, I think next class we'll start out with example 8. Yeah, and then we'll start with some other stuff. Okay. Yeah.